Hello, everyone. I'm Abdelhamid. I'm a graduate student. So eFargo is an organization that originated as part of the Georgetown Energy Prize, and our city, Fargo, North Dakota, actually won first place, and that was through multiple communal, university, and school-wide energy reduction and energy saving activities. And one really important one was the energy challenge, or the K-12 challenge, that we implemented in the Fargo public schools. And that was important because it allowed us to gain access to utility data of almost 12 school buildings, so we can actually allow the students in those schools to compete and to measure which school saved the most energy. So with that, just a quick overview of the pilot project. The first question that we asked ourselves when we first started working on this research project was, how can we measure building energy use without accessing utility data and keeping in mind privacy concerns? So really our aim was to develop this external imaging and external documentation process that would allow us to gain an estimation or a ranking of energy performance without having to access its bills and its data and its meters. And then our process for the pilot project included documenting and constructing 3D models of 3 public school buildings, and then analyzing and validating our methods with the baseline data. For this specific project, what we introduced is the thermography piece, and we really believe that thermography gives us access to both temperature values, to both color values, that we will use as additional ranking methods in this study. So the table below here shows you the utility data that we had access to for all the schools. And what we do with this table is we use these values as a baseline, where at the end of the project, we compare our results to these numbers to see how successful our methods are. The first step is the documentation. And so this involved photographing the buildings from the exterior, and we did that through both aerial and walk around. So walk around included just walking around the building and capturing it with a camera, and aerial included drone photography. And we had a camera that actually captured a digital image and a thermal image at the same time. Our second step is the 3D model construction, and we did that in Rhino. We actually retrieved building outlines in Google Earth and Google Street View, and that helped us create mass models of the schools and to measure their height, to measure their dimensions. And then from that, we actually went through like this very rigorous selection of images, because we ended up with almost 500 images per school. And then after that, we worked with the thermal images in like both FLIR tools, in Lightroom, and in Photoshop to edit, to crop, to access thermal properties of these images. And then at the very end, we go through this process of attaching the surface images both to the roof and to the elevation as well. This is a timeline that we had diagrammed for our study, and it really shows 3 major points, which is going over like the background research, the documentation process, and then going through a complexity study, and this was included in the pilot project, and then going over external documentation to 3D model construction, and then ending up with 4 ranking systems, 3 of which we have devised, and then we compare it against the baseline data, which is the utility data provided by the schools. So with that, one of our first ranking methods that we actually came up with in the pilot project was the geometric one, and that included extracting parameters from the Rhino model, and this was done through a Grasshopper script, extracting parameters of total building area, total building volume, window to wall ratio, opening to wall ratio, and this was all based on research that we had done of parameters that we believe have a significant impact on energy performance. After that, we went into 2 thermographic ranking methods. One was the color, And this was really extracting the amount of red, green, or blue in each of the thermal images. And again, this was again done through a Grasshopper script. And we also added weightage to each of the pixel pixel colors. We associated green with the negative value and blue with the positive value due to is extracting temperature values of each pixel of the thermal image. And we do that through FLIR Thermal Studio, which is a process that allows us to export CSV files where each cell in the spreadsheet is actually a temperature value of an image pixel. And doing that, we actually sample all the images and then we add all these together and then divide it by the square footage of each school to arrive at a value that is unique for this thermographic temperature analysis of each school. Our results were, again, compared to the baseline utility data. This here shows the pixel color analysis and then the temperature edit. And then at the bottom here is the geometric ranking. And then based on those, we actually, in the temperature scale data, we have Lewis and Clark. They matched our baseline data. And we believe that only one school matched, and that's probably because we actually photographed these schools at different times along the semester. We had Lewis and Clark and Longfellow be photographed early in April, and the other three were late in May. And although they were all photographed before sunrise, that might still have, the weather might still have an impact. And then for the geometric ranking, we actually had Bennett, Carlben, and Jefferson be placed correctly, and that's specifically related to the window to wall ratio. And then according to the surface area to volume ratio, Lewis and Clark and Longfellow aligned with the baseline data as well. And that takes us to looking at, what could we possibly do better? What are our opportunities for future work? And then we believe that one limitation that we had was that our 3D model construction process was entirely manual. We had to go through and select images and attach them to the 3D model. And if we were using another photogrammetry program, it would make things a lot faster and a lot more efficient. And we have tried programs such as Alice Vision and Meshroom, but they haven't been successful with our work. And then another point could have been that we overlooked data as part of the image selection process, again, because this is manual. And then last thing is that we also want to note that this research is limited because the utility data that we use as a baseline is based on the 2015-2016 academic year, and our images were taken in spring of 2019.